Hello children, I am Rizwan. Welcome to an exciting lesson on Thales and Pythagoras Theorems, two fundamental concepts in geometry. In this lesson, we will explore the basic proportionality theorem, also known as Thales theorem, and its converse. We will uncover the remarkable properties of parallel lines, angle bisectors, and the proportional division of sides in a triangle. Additionally, we will dive into the renowned Pythagoras theorem, which reveals the hidden relationships between the sides of right angle triangles. Through engaging examples and proofs, we will witness the practical applications of these theorems in solving intriguing real life and geometric problems. Get ready to unlock the secrets of triangles and discover the fascinating world of Thales and Pythagoras. Learning outcomes. At the end of this lesson, you will be able to understand and apply the basic proportionality theorem and its converse. Understand the Pythagoras theorem for right angle triangles. Apply the Pythagoras theorem to solve problems in right angle triangles. Keywords from this lesson are basic proportionality theorem, Thales theorem, proportion, parallel lines, converse, angle bisector, Pythagoras theorem, right angle triangle, hypotenuse, similarity of triangles. Basic proportionality theorem. The basic proportionality theorem was first stated by Thales, a Greek mathematician. Hence, it is also known as Thales theorem. Thales first initiated and formulated the theoretical study of geometry to make astronomy a more exact science. What is this theorem that Thales found important for the study of astronomy? Let us find it out. The basic proportionality theorem. The basic proportionality theorem can be abbreviated as BPT. States that if a line is parallel to a side of a triangle that intersects the other sides into two distinct points, then the line divides those sides in proportion. In the figure alongside, if we consider DE is parallel to BC, then according to the theorem, AD by BD is equal to AE by CE. Let's not stop at the statement. We need to find a proof that is true. So, shall we begin? Proof of BPT. Given in triangle ABC, DE is parallel to BC. Line DE intersects side AB and AC in points D and E respectively. To prove AD by BD is equal to AE by CE. Construction. Draw EF perpendicular to AD and DG perpendicular to AE and join the segments BE and CD. Proof. Area of triangle is equal to half into base into height. In triangle ADE and triangle BDE, area ADE by area DBE is equal to 12 into AD into EF by 12 into DB into EF, which is equal to AD by BD. Consider it as equation 1. In triangle ADE and triangle CDE, area ADE by area ECD is equal to 12 into AE into DG by 12 into EC into DG, which is equal to AE by EC. Consider it as equation 2. Note that triangle DBE and triangle ECD have a common base DE and lie between the same parallels DE and BC. Also, we know that triangles having the same base and lying between the same parallels are equal in area. So, we can say that area of triangle DBE is equal to area of triangle ECD. Therefore, area of triangle ADE by area of triangle BDE is equal to area of triangle ADE by area of triangle CDE. Therefore, AD by BD is equal to AE by CE. Hence proved. Converse of basic proportionality theorem. Statement: if a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. If AD by DE is equal to AE by EC, then DE parallel to BC. Prove that DE parallel to BC. Given in triangle ABC, D and E are 2 points of AB and AC respectively, such that AD by DE is equal to AE by EC. Consider it as equation 1. Let us assume that in triangle ABC, point F is an intersect on the side AC. So, we can apply Thales theorem. AD by DB is equal to AF by FC. Consider it as equation 2. Simplify 1 and 2, we get AE by EC is equal to AF by FC. Adding 1 on both sides, AE by EC plus 1 is equal to AF by FC plus 1. Taking LCM, we get EC plus AE by EC is equal to FC plus AF by FC. AC by EC is equal to AC by FC, which is equal to EC is equal to FC. From the above, we can say that point E and F coincide on AC. That is, DF coincides with DE. Since DF is parallel to BC, DE is also parallel to BC. Hence, the converse of the basic proportionality theorem is proved. Let us see one example. In triangle ABC, segment AD is the angle bisector of angle BAC. BD is equal to 6, DC is equal to 8, AB is equal to 15. Find AC. Solution. Segment AD bisects angle BAC, which is given. AB by AC is equal to BD by DC by angle bisector property. Assume AC is equal to x. Now substitute the values. We get 15 by x is equal to 6 by 8. By cross multiplication, we get 15 into 8 is equal to 6 into x. Now solve for x. We get x is equal to 15 into 8 by 6, which is equal to 20. Therefore, AC is equal to 20. Pythagoras theorem and its applications. You are at one end of the amusement park and your friend is at other end. There are two ways you can reach your friend. Either you go west for 3 miles and then walk north for another 4 miles, which make it a total of 7 miles. Or you go right through the center of the amusement park walking diagonally. You need to find the distance you need to travel for the second option. How do you do it? Well, you take the help of the Pythagoras theorem. The Pythagoras theorem. Let's have a look at what Mr. Pythagoras stated when he came up with the theorem. Statement: in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. To understand it better, we break down the statement. A right angle triangle is a triangle with a 90-degree angle. The hypotenuse is the longest side of the right angle triangle. The remaining sides of the triangle are called the base and the perpendicular. In the diagram above, angle ABC is a right angle. AC is the hypotenuse, AB is known as the perpendicular, and BC is the base. So, according to Pythagoras theorem, AC square is equal to AB square plus BC square. But then should we merely trust a single statement? I don't think so. We need proof. Proof of the Pythagoras theorem using similarity of triangles. Given in triangle ABC, M angle ABC is equal to 90 degrees. Construction: BD is perpendicular on side AC. To prove AC square is equal to AB square plus BC square. Proof: in triangle ABC, M angle ABC is equal to 90 degrees, which is given. Segment BD is perpendicular to hypotenuse AC by construction. Therefore, triangle ADB similar to triangle ABC similar to triangle BDC, similarity of a right angle triangle. Triangle ABC similar to triangle ADB. AB by AC is equal to AD by AB, congruent sides of similar triangles. AB square is equal to AD into AC. Consider it as equation 1. Triangle BDC similar to triangle ABC. CD by BC is equal to BC by AC, congruent sides of similar triangles. BC square is equal to CD into AC. Consider it as equation 2. Adding the equations 1 and 2, we get AB square plus BC square is equal to AD into AC plus CD into AC. AB square plus BC square is equal to AC into AD plus CD. Since AD plus CD is equal to AC, therefore AC square is equal to AB square plus BC square. Hence proved. There also exists a converse of the Pythagoras theorem that states if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. Let us see one example. In a right angle triangle LMN, LM is 3, MN is 4, find the hypotenuse LN. Solution. Given LM is equal to 3, MN is equal to 4. Find hypotenuse LN. Since triangle LMN is a right angle triangle, we use Pythagoras theorem to find the hypotenuse. By Pythagoras theorem, Ln square is equal to Lm square plus Mn square. That is equal to 3 square plus 4 square, which is equal to 9 plus 16. So, Ln square is equal to 25. Ln is equal to root 25, which is equal to 5. Therefore, Lm is 5. Let us see another example. In a right angle triangle PQR, PQ is 5 and hypotenuse PR is 13. Find the base QR. Solution. Given PQ is 5, PR is equal to 13. Find QR. Since triangle PQR is a right angle triangle, we use Pythagoras theorem to find side QR. By Pythagoras theorem, PR square is equal to PQ square plus QR square. That is 13 square is equal to 5 square plus QR square. Which is equal to 169 is equal to 25 plus QR square. Now, QR square is equal to 169 minus 25. QR is equal to root over 144, which is equal to 12. Therefore, QR is 12. Points to remember. Basic Proportionality Theorem states that a line parallel to one side of a triangle divides the other sides proportionally. The converse of Basic Proportionality Theorem states that if a line divides any two sides of a triangle in the same ratio, it is parallel to the third side. Pythagoras Theorem. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. Thanks for watching.